In this presentation, I'm going to cover the following topics: the traditional workflow of construction design, the future workflows and our vision of construction design, how we detail multiple disciplines with Tekla using the API, why Tekla, proof of concepts in current projects, and then our final conclusions. Take you straight into it. The current and traditional workflows of construction design really start with the master model. So this master model is generally done in a software suite or platforms such as Revit, Aviva Smart Plant, and so on. And the general engineering is done inside here, and I'm sure most of you are familiar with this, where the engineer then does the layout in here, goes out to the FEA or analysis platforms, designs the structural steel, and then from there on it's exported to the structural steel detailing and the MEP detailing using Tekla structures or PDMS or whatever you use. Then we do a cross-reference between the two, so we export them as IFCs, the various disciplines, import them into the two packages or platforms, do clash detection and that sort of thing, and from there we export out to the BIM interfacing from those packages to interface. The big problem lies when there's a change request and when a change happens. So the change then is required to happen within the master model, and we need to go through the entire step again, or all of these steps again, to finalize our final deliverable, which is generally the fabrication detail drawings. In our experience in our future workflow of construction design is to use and utilize Tekla only as a platform. So instead of trying to use various other platforms that then push and pull into Tekla or a detailing platform, we can do all of the detailing within Tekla structures. This includes the detailing of structural steel, which is pretty good at the moment, civil detailing, and then with some add-ons that we've generated and developed, we can detail the piping as well as ducting and cable racking inside the Tekla platform. This means that when there's a change request, and it doesn't matter where we are in the process of the detailing, we are able to make a change to that model. So how do we detail multiple disciplines with Tekla using the API? Traditional platforms, as you can see in the little blue thing over there, is pretty good at doing the layouts of structural steel, civil works, cabling, and ducting, but it lacks the ability to detail any of these disciplines. Tekla, on the other hand, is good at laying out structural steel and civil, detailing and laying out of structural steel and civil works, but not really good at detailing piping, cabling, ducting, or either scaffolding. Using Tekla with add-ons allows us to detail more than just the steelwork. So using some of our add-ons, we are able to detail the piping, the cabling, in the future the ducting, and scaffolding using ScafPlan solution. Just to start off, this is a demo of our piping solution within Tekla structures. So as you can see, that's the structural model, and I know it's very simple, but I just did it as quick as I could. You can add elbows to the pipes. The pipes drive the size of the elbow and the standard, and you're able to change the specifications of those elbows within the user interface. Because it's standard Tekla structures, we're able to split or use the standard Tekla functionality and add in T-pieces. And modify those T-pieces to add, for instance, if you need flanges to all three sides or wherever you require the flanges to go. You can add some single flanges to it. And that's just the flange builder or configurator. And then by utilizing the Tekla functionality, you can edit the flange and move it around by dragging the handles. Also add some reducers. And utilizing the user input forms, we can modify the reducer to concentric or eccentric, but also add flanges to either side or wherever you feel like or required from the engineers. From here we can apply numbering to the pipelines itself, create create detailed drawings and reports. And because it's Tekla and it's database driven, we are able to create custom reports. Some of the reports that we currently create, buyout lists, bolt assembly lists, pipe material lists, and line breakdown lists. But I mean, the possibilities are endless using Tekla. We're also able to generate detailed fabrication drawings of all the spool pieces. So instead of delivering isometrics, because most of the artisans nowadays are unable to read these isometrics, we deliver detailed fabrication drawings of all the spools. And then for those of you who don't know Tekla, the standard functionality of detailing the structural steel is pretty easy and simple. I don't think there's a better detailing tool out there. Adding connections are pretty simple. Drag and drop of structural steel members. Adding of some base plates, and your structure is basically ready for issuing fabrication. Now, one of the advanced features of being able to do the piping within the structural model is to add dynamic pipe supports. So by moving the structural steel, you can see the pipe support adjusts automatically. And if you make any changes to the piping itself, you'll see the pipe supports adjust. This saves us a lot of time, and if anyone works with process engineers, you know how often they like to make changes to the piping, yeah? From here on, we can generate the detailed fabrication drawings of the structural steelwork and the pipe supports. And that's just standard Tekla functionality. We're also able to detail cabling within Tekla. So the yellow beams, poly beams that we've modeled in there are just the basic routings of where we'd like the cabling to go, or cable racking to go. You can see the cable racking is detailed instantly, dependent on the specification that you've added or applied. And then we can create detailed reports and buyout lists to purchase and supply these pipe supports to site. But it doesn't end there. We're also able to support the cabling from the structural steel. Now, one of the benefits of supporting cabling from structural steel, if anyone has ever worked with an electrical engineer on site, they decide where the cable racking goes and not for us. By drilling or pre-drilling the structural steel, we are now able to kind of force them where they're supposed to support the cable racking. You don't bump your head. And we have various different types of supports, as you can see there. Quite an easy user interface, and most detailers get to use this pretty quickly. So again, because the cable racking supports are dynamic, you'll see when you change the offset of that cable support, or the cable rack itself, the supports will automatically adjust. And note, every detail is modeled in, so we can create very detailed bill of materials and take the guesswork out of supplying cabling and cable racking. So why Tekla, in our opinion? Tekla is one of the better database-driven BIM packages or platforms. So what this really means, there's no sketches that drives anything within inside the model. We have coordinates, and we just apply specific attributes to those coordinates. It's got a modern and robust architecture. Tekla wasn't built off of a 2D platform where they tried to convert it into 3D. Tekla was built from the ground up, and in my opinion, one of the stronger 3D platforms existing at the moment. Tekla is construction software, being able to deliver LOD 400 BIM models. We can generate instant NC files from it, customizable reporting due to it being database driven. An elaborative open API allows us to generate and create the add-ons that you saw earlier. Automated fabrication drawings, built-in document management for revisions and revision control and everything else required, and it can handle very large models in comparison to many other platforms out there. What are the future deliverables for projects? At the moment we deliver fabrication details, and in my opinion we will always be delivering fabrication details, be it in what form or shape, we're not sure, but at the moment it's 2D, maybe we'll go into 3D one day. Not so sure if it's going to work with some fabricators. A constructible BIM model, asset management using BIM models, and automation of repeat geometries. And as most of you know, fabrication details are generally detailed fabrication drawings of assembly, single parts, general arrangements. But now we can, utilizing our piping add-on, we can deliver these detailed drawings for not only the structural steel, but the piping as well, and then complete with it NC cutting files and customizable reports. Constructible BIM model, and we touched on this in the keynote speak, but one of the future deliverables, in my opinion, and this entire plant was actually built in Tanzania without any general arrangement drawings. All of the required information is attached to every object inside the model, including the piping specification, elbow specification, line numbers, P&ID number, and very importantly, the spool number. So that spool number is generally marked on the actual spool piece in fabrication. So when it lands on site, we at least know where it goes, because I'm sure some of us know that when the piping lands on site, we don't know where to put the spool piece or where it goes. Yeah. Also able to distinguish what bolt sizes we need to use between two flanges and the quantity of bolts. We've had it a few times before where people use all the long bolts before they use the short bolts, and then you get to the end of the project in the middle of Tanzania and you have to ship thousands of bolts up to site. You can obtain the information about the profiles, as most of you may know who's used Trimble Connect, masses, paint area, whatever you require. And again, the bolts and bolt specifications to bolt the structural steel together. So this was a multi-discipline model in this specific plant, or this is one of our test models where we tested the piping, and there was about 2 kilometers, 3 kilometers of HDPE piping and roughly about 4 kilometers of steel piping in this plant. All done within one model, utilizing model share and various teams all over the world. We were able to detail all the disciplines at the same time. Then asset management using BIM models. Now, this is very important for us as plant, not for us, but for plant owners, especially when something like COVID hits and we're not allowed to go to site. We still need to be able to manage those sites. Now, by being able to click on, for instance, that pump and obtaining all of the information, including pump curves, pump information, invoicing, last time serviced, servicing schedules, and whatever from the 3D model, for us is an important tool, because it means that the plant manager doesn't ever have to go to site anymore to maintain his plant. Automation in Tekla. Now, a lot of you may have heard of parametric modeling. We don't use parametric modeling, we use something called programmatic modeling. The big downsides to parametric modeling, in our opinion, is you have to add parameters and formulas to already modeled items. So you have to model something and then add attributes to it. You have to use very complex formulas inside the model environment that often breaks. You're stuck with that parametric model, so you can't generally explode it and make any custom alterations to it because it's so dependent on all the formulas inside the modeling platform. Only the person who built the parametric model can really edit it. in our experience. It's generally so complicated with inside the model that no one can go in and make any changes. It's very slow and resource intensive. We're not able to nest programs, and I'll just explain that in the programmatic side. And you're limited to the logical statements given to you by the owner of the platform itself. Programmatic, on the other hand, we use the software functions to model from absolutely nothing. So utilizing C# outside of Tekla, we are able to model the things without even touching Tekla. And I'll show you in one of the next slides coming up how and what I mean by that. Standard model with no relation to constraints, formulas inside the platform. So it means that all the formula sits outside of Tekla structures or the modeling platform. And then nesting of programs allows us fast detailing. So what that means is we can create various smaller applications and call those smaller applications within the main application. And to explain that, if you have two brace members, you want to attach a brace member here, in the program you can create a connection for these two braces to talk to each other. And using the program we can call that connection model up at numerous occasions. Instead of in parametric modeling, you have to detail that connection every time. And then C#, the code allows us for unlimited calculations and logic because we're not constrained to whatever the software vendor gave us. You can automate any repeat geometry. In South Africa, we deal with a lot of conveyors and conveyor designs and detailing of them. And this is a simple process of how we start and deliver a detailed conveyor to site. We start with the belt line and where we would like the belt to run. That's a LOD 100. And everything, that belt line drives the entire conveyor. From there we go over to level of detail 200, which has all the major objects and geometries of this belt. Level of detail 300 takes those geometries and breaks them up into smaller pieces. 350 takes those smaller pieces and converts it to structural steel. Level of detail 400 then connects it up. And 450 is generally a 3D scan on site. We import that scan into Tekla, and then in level of detail 500 we are able to update the model that is exactly what is on site. So this is just an example of our automated conveyor. That's the belt line over there. So we've defined where the belt is going to run on site. From there we convert it to a LOD 200 model, which are mainly just the building blocks. Once we are happy with the general layout of where the conveyor is going to run, we convert it to a level of detail 300. Now in here you'll see all the supports I added and general walkway locations and whatever else is required to finalize the layout of your conveyor. From here we go into level of detail 350. This converts those model items to structural steel members. And from here we can export to an analysis software, do the design and update before we start the detailing. Please note that there was no manual detailing done to create this model. This was all done using the API. From there we go over to level of detail 400, where we include all of the detailed connections, as well as idlers. It includes even the packers. So for those of you who understand conveyors, when you have a curved conveyor, concave conveyor, you have to pack the idlers because you have straight sections. This application automatically calculates the quantity of packers required. All the detailed connections are in, and we're ready to issue this for cutting using NC files, create the detailed fabrication drawings and reporting for the purchasing of materials and bolts and bought out items. This workflow takes a normal engineering company roughly about, depending on your previous projects, but roughly about 160 hours to get to the stage. It takes us no longer than 1 minute and 38 seconds. We do roughly about 100 conveyors a year, so you can make the math. It saves us a lot of time. Some of our case studies. Piping we've done using Tekla, so you can see the level of detail of the piping. These were all done within structural and civil models. Then we did some cabling. Cabling is a new BIM modeling element. Not many people are actually modeling the cabling. They're still leaving it up to the engineers. So there's a lot for us to learn in this. Civils and structural steel. So you can see the civil detailing complete with the rebar detailing, and the structural steel was all detailed in Tekla structures. And then some one platform projects. So there you can see structural steel piping and cable racking all within one Tekla model. Then the new generation of brownfield projects, and this for us is also a big thing in South Africa. Plants are deteriorating every day, and we need to make upgrades to those plants. There's no such thing as an as-built drawing existent in most plants that we've been on, and if it is, you can't trust it because they didn't model in the cable racking. So you never know where there's a cable rack that's going to be in the way. In this video you can see we imported the 3D scan into Tekla structures, and then we are able to detail every connection and pipe support, in this case, to attach to existing infrastructure. Using the X7, Trimble X7 laser scanner, we are actually able to do site layout where we import this model into the tablet on site, and we are able to point the laser using the layout tools to where exactly they need to pre-drill the holes before the structural steel arrives on site. As you can see, some civil detailing and design done with inside the Tekla model and the 3D scan to ensure that everything is going to fit. Utilizing of existing pipe racks to support new piping. And just ensuring that there are no clashes on site. So by fabricating elements off site, I'm sure you know, it saves us a lot of time in construction. So we are able to fabricate all of the structural supports and piping spools, deliver it on site, have the bolts or the holes pre-drilled for the structural steel, and allows us to just bolt it in without having any issues going forwards. My final conclusion, use Tekla as a platform from the start of every project. It will save us a lot of time, money, and actually get us to get our projects done in time, because it never happens. By using the API, we can deliver and develop add-ons to efficiently detail various disciplines within Tekla. We can repeat geometries, or we can automate repeat geometries, and then by importing the 3D scans into Tekla, we are able to deliver accurate level of detail 500 models. Thank you.